Hi, it's a privilege to brief you about the Master Certification course in Battery Management Algorithm Software Development. As a part of this course, we have the variety of learning activities that helps you to gain a mastery of developing the BMS software. To make this happen, the first few modules of our course consist of understanding the battery and battery characteristics, because you are writing a software for the cell or the pack. Henceforth, it is very important for you to know what are those typical inherent nature and characteristics of those cells are. To learn all of this, so we have a state-of-art laboratory that is established at Decibels Lab. With the help of this lab, we help our learners to get a practical and a hands-on learning experience to know about the battery characteristics and the cell characteristics. With the help of this lab, our learners can learn on conducting a variety of tests to know characteristics such as open circuit voltage. How do you get that open circuit voltage by conducting a test? And how do you use this data for a part of writing your BMS software? Also, conducting a variety of capacity tests, because the capacity is not a constant component, which is dependent upon variety of conditions such as the different C rates and also different temperatures, and also based on the age. Apart from this, we also have functions of round trip efficiency, internal resistance, and variety of other functions. So our learners who has taken these courses can come to the lab facility, learn by practically conducting the tests with the help of these equipments. Apart from this, we have collected large amount of data in the past. You also get an access to the data. So when you are developing an algorithm, you know how the cell behaves, and for what type of cell, what type of chemistry, what type of the consideration that you want to make in writing your BMS software. So once our learner gets a very solid foundation to know about the cell, then they learn to understand on how to write a software. To write a software, we use MATLAB and Simulink and also Stateflow and n number of other toolboxes in developing the software, because we have to do mid testing, SIL testing, and also code generation and a variety of activities. So we teach the foundation of MATLAB and Simulink and then also the Stateflow. Once our learners learn all of this, we get an application perspective of writing an algorithm for a single cell BMS. So let me walk you out and show you the hardware that we have developed to teach our students practically on how to develop and deploy the algorithms for a single cell BMS. So as a part of practical learning activity, because we believe in teaching our courses with a full-fledged hands-on learning. A lot of learning can happen through simulation, but the real learning and an experience that you can build as a part of this course is by deploying the algorithms that you have developed. Where our course has a blend of online learning and offline learning. In the online learning, you get an access to the recorded course lectures through the Decibels LMS. So you can sit anywhere across the world at your own convenient time, and you can work on those modules to develop the algorithms. So once you have done all of those efforts in developing the algorithms, then you get a visit to our lab in Bangalore. So this is the hardware that we have developed, so our student can connect their PC and MATLAB software and deploy those algorithms directly onto the microcontroller and then take the journey of the BMS testing. As a part of this, we are using NXP based microcontrollers as a part of this test setup. So it is a process of which you get to learn how to configure your device drivers for the NXP, how to write your application software, how to integrate your application software and a base software, and then the process of where you will be able to deploy the program into the hardware. And then you can have a process of charging the battery at variety of conditions, and we also have an option of discharging the battery for a variety of C rates. We have an option of configuring these cells for the NMC, also for the LFP. So when you write your algorithms, you can check whether your algorithm works well for what kind of test cases, does your algorithm is really able to function as it is expected and perform all the voltage protections, current protection, temperature protections, SOC estimation algorithms, and all the variety of algorithms that you can deploy onto a single cell board. So this visit of the lab where you get an hands-on experience will build you a lot of confidence. So this doesn't stop here as a part of the hardware kit that we have developed here. So then the learning journey continues through our online learning modules and that we have. And once you finish our part of our online learning modules where you learn about the Kalman filters, external Kalman filters, and cell balancing algorithms and all of that, then you get to visit a practical lab where you have test setups here which are designed to conduct variety of deployment of your software and also conducting the test cases. So as a part of it, we have several test benches where can be utilized for deploying your algorithms onto the hardware level. And then we have the battery packs which are pre-configured, and we have a charger, then we have a load. Programs that we have written function well as per the expected requirements in place. So to the help of this journey and practical learning, you get to build a total confidence and understanding on how to write the battery management system software. And it is not just a software, but you understand the process of developing the BMS software, where it starts with understanding how to write and use the program development with the help of MATLAB and Simulink, and then the Stateflow, and then the code generation, configuration of the hardware, target hardwares, and then performing the mill testing, SIL testing requirements, and also to learn on model-based FBD standards that we can follow in creating the models, and then finally learning how to work with real-time hardware, integrating the hardware to the software functions that you make, and then finally deploying into the real-time battery management systems. So this program can open up a lot of opportunities for you if you're aspiring to become an algorithm engineer to develop the BMS software, and also the software for any other applications with the help of model-based design engineering. Thank you.